Hey everybody, welcome to your third lesson. In this lesson we're going to be learning how to convert unit rates. That means we're changing from one thing to another thing. Our objective is to convert rates using unit rates and dimensional analysis. So I'm going to go over what that actually means in this lesson. Our standards that we're going to be addressing is 7th grade standard ratios and proportion standard number 2, 7th grade ratios and proportion standard number 3. Let's get going on today's lesson. So we're on to vocab. We have 2 vocab words for this one. The first word is unit ratio. It's a unit rate where the bottom number or the denominator is 1 unit. Kind of like what we defined a unit rate as. The denominator is 1. So it's a fraction with the bottom being 1. Dimensional analysis is the process of including units of measurements when you compute. So that really means that maybe we might use like there's 3 feet in a yard, there's 12 inches in a foot, or some type of unit of measurement to figure out a solution to an answer. We're going to go ahead and, on the next slide, write down some of the different units of measurements that we might know. Okay? Make sure you pause that and make sure you copy down every piece of that. Let's get going. Make sure you pause the video. I know this looks like a lot of information, but these are different units of measurement that we might use to do dimensional analysis. There's 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 7 days in a week. These are ones that most of us probably know. Here we have there's 12 inches in a foot, 3 feet in a yard, 5,280 feet in 1 mile, 100 centimeters in 1 meter, 1,000 meters in 1 kilometer, 2.54 centimeters in 1 inch. And over here we have just a few extra ones. We have 1 pound is equal to 16 ounces, 4 quarts in a gallon, 2 pints in a cup, 8 ounces in 1 cup, and 2 cups in 1 pint. If we need any other units of measurement, I'll make sure that we go over those in class, but I would like you to make sure that you pause, copy down all these. These are ones that we might use. What we do with these is we can write them as a fraction. We can put one of these on top, one of these on bottom. And it doesn't matter how we do it, but that's what's going to help us when we're actually solving to change from one unit to another. We need to know this information. So make sure you have this because we might be referencing it in today's lesson. For example 1, pause the video, copy down the entire problem. Also make sure you add the rule to cancel out. This is a rule that I like to use that will help us when we're doing dimensional analysis. It says in order to cancel any unit out, what you have on top, you have to put on bottom. And I'll be referencing that rule as we go through today's lesson. So here's our problem. It says that a remote control car travels at a rate of 10 feet per second. How many inches per second is this? So what we're doing is we're going from feet a second to inches a second. And this is one of the skills that you could do whenever writing a problem out is you could underline the units of measurement that you know that you're going to need. I'm going to need feet in seconds. I'm going to need inches in seconds as my final answer. So what we're going to have to do is we're going to have to change things from one unit to another unit by using that dimensional analysis. And I'll show you how that all works. So the first thing it says, a remote control car travels at a rate of 10 feet per second. Well, we learned in lesson 1 and we talked about in lesson 2 that a rate is when the denominator is 1. So we need to change that information of the first sentence into a fraction. 10 feet over 1 second. So I have my fraction for my rate. Now, what we need to know is what are we trying to get this to change to? So if we look at this, it says that we have feet, but now it says we have inches, seconds, and seconds. So that means that we're not changing the bottom. Since it still says that we are using seconds, we're still going to have seconds on the bottom. But the unit they want us to put on the top is actually they want us to put the inches on top. So what we have to do is we have to look back at that list of units of measurements and see if there's something that has something to do with feet and inches, because this is where it's changing. It's changing from feet to inches. And we would write that as a rate as ourselves. We'd write it as a fraction. And what we do with that fraction is we can flip it one way or another so we can cancel something out. So I know, based on our units of measurement, that there are 12 inches equals 1 foot. So what that rule over there on the right actually means is I'm going to rewrite this as a fraction. And if I want to cancel something out, whatever I have on top, and if I want to cancel out the top, if it's on top, I have to take this information and now rewrite it as a fraction where that unit that's on top is now on the bottom. So this is what that rule means. In order to cancel any unit out, what you have on top, you have to have on bottom. I want to cancel out feet because I want inches, so I have to use something that has feet and inches based on units of measurement. If I want to cancel this out on top, I have to put it on bottom. So we rewrite the unit of measurement so it's a fraction. If it's on top, it's on bottom. The unit of measurement is now going to cancel out. Now all we have to do is say, what is 10 times 12? Well, 10 times 12 is 120. 1 times 1 is 1. And now we have changed from feet to inches because we canceled out our units. And that's what this whole lesson's about, is the ability to cancel out. In order to cancel out, though, we have to know our unit of measurement to get rid of. And we have to see what is our end goal. We start with our original problem and see what's our end goal and cancel out as we go. To cancel out, what you have on top, you have to have on bottom, and they cancel. Let's do another problem. Here we are at example 2. Example 2 says that we're going to convert 15 yards per hour to inches per hour. So again, we're going to need dimensional analysis, which means that we're going to use units of measurement to figure out this answer. So I need to first write this down as a unit rate. So I know it's 15 yards per hour. So I'm doing yards and hours. But now I'm changing to inches an hour. So I'm going to start this kind of like we did the last one. 15 YD for yards over 1 HR for hour. And I know my end goal all the way over here is I want inches over hours. So what we have to do is we need to think about something that involves yards and inches. But when we look at our units of measurement that we wrote in our original at the very start, we didn't have anything that told us how to go from yards to inches. But we did have something that was dealing with yards. We know that there are 3 feet in 1 yard. Okay. Did we have something to deal with this in inches? So we look back at that sheet that we started with, or that units of measurement we started with, and we know that there are 12 inches in 1 foot. So in this problem, we're not just using 1 unit of measurement, we're actually going to use 2 units of measurement, because now we have inches, and we want inches. We have hours, we still want hours, so we're not changing the bottom. The bottom's going to stay the same. The only thing we're going to change is we're going to change the top in yards to inches. To do this, we're now going to use these units of measurement to cancel out units. What I see on top, in order to get rid of it, I have to put it on bottom. So we're going to take this unit of measurement and write it like a fraction, but the yards has to be on the bottom in order to cancel out that unit of measurement. So we're going to multiply it by 3 feet over 1 yard. Now, going over our rule, in order to cancel something out, what you see on top has to be on bottom. Yards are on top and bottom. We can cancel out the label of yards. Now I have feet. But our answer doesn't want us to have feet, it wants us to have inches. So what we have to do is we have to take the inches and feet measurement that we have, which there are 12 inches in 1 foot. We're going to take that and write it like a fraction. And we're going to write it like a fraction in order to cancel out units. And again, what we have on top, we have to put on bottom. Since we have feet on top and we want to cancel feet out, we need to put the feet on the bottom. So we're going to multiply it by 1 foot over 12 inches. And now we see that we have feet on top, feet on the bottom. These cancel out. If we look at the top, we should have the right unit of measurement. Since yards is gone, feet's gone, the only unit of measurement is inches. And we want inches on top. That means we're doing it right. We look at bottom. We have hours, yards is gone, feet's gone, so we only have hours, and we want hours over here. So this means that we have set up our problem right. Now we're actually going to multiply. I'm going to use a calculator to multiply. We multiply everything on the top. 15 times 3 times 12. That equals 540. And then we multiply everything on bottom. 1 times 1 times 1 equals 1 hour. So, if we were moving at a speed of 15 yards per hour, we would be moving at 540 inches in 1 hour. And we have converted our unit rates. We changed from yards to inches. And a reminder to do that, whatever you have on top, cancel out by putting on bottom. And multiply straight across. Make sure you have your units of measurement so you can cancel out units. Let's go ahead and try some more. Example 3. So this one says that a swordfish can swim at a rate of 60 miles per hour. It's pretty fast. How many feet per hour is this? So we have to change our units. I'm going to go back to the word problem and underline what units I have. Miles and hours. And then it says feet and hours. So now I know that I'm going to be using miles and hours, and I'm going to use feet and hours. So the one unit that's really changing is my unit of measurement of distance, miles to feet. So I need to know something about a mile and a foot. Well, I know, based on our units of measurement that we wrote at the very beginning, that there's 5,280 feet equals 1 mile. Okay, so this is a unit of measurement that I'm going to use to solve this problem. Before we do that, though, we have to actually write this information as a unit rate. So, 60 miles over 1 hour. We look at this and we see that feet per hour means that we want feet on top and we want hours on the bottom. As we learned in example 1 and example 2, in order to cancel something out, if I want to cancel out miles and change it to feet, I have to put the miles, or the information I have from a measurement, on the bottom in order to cancel out. So, 1 mile is going to go on the bottom, and 5,280 feet is going to go on the top. And we're just going to multiply. But before we do that, we have to see, can we cancel out our units? Well, there's miles on top, miles on bottom. They cancel out. Do I have feet on top? That's the only thing on top. We're good to go. Do I have hours on bottom? That's the only thing on bottom. Now that the bottom units I've canceled, we're good to go. So this means that we are good to multiply straight across. 1 times 1, that's 1. 60 times 5,280, I'm going to use a calculator. When I take 60 times 5,280, I get 316,800. So what this really means is that if a swordfish can swim at 60 miles per hour, it's swimming 316,800 feet in 1 hour. That's a huge amount of distance for a fish to swim. Let's go ahead and try another problem. We're on to example 4. We're moving at a good speed. Example 4. The Shinkansen passenger train of Japan travels at a rate of 300 kilometers per hour. How many meters per hour is the speed? So I'm going to underline the units of measurement in the problem. This helps me out. Kilometers per hour. How many meters per hour is this? So I see I have kilometers and hours. I have meters and hours. So we're going to start with something that deals with kilometers in an hour. And we're going to change it to something that deals with meters and hours. So we need to go back to our chart that we started with at the very beginning that has the different units of measurements. Something that deals with kilometers and meters, because hours are still on the bottom. Well, I know that there's 1,000 meters is equal to 1 kilometer. So this unit of measurements is what's going to help us solve this problem. Go back to the problem to actually write our rate. Our rate is our fraction. 300 kilometers per hour. So 300 kilometers over 1 hour. And we're going to use this based off our rule that we talked about in 1, 2, and 3. Since we have kilometers on top and we know we want to change it to meters, we have to put the kilometer, or the information we have right here, as a fraction, where kilometers is on the bottom and the 1,000 meters is on the top. Now, we're going to see if we're done. Kilometers cancel out because it's on top and bottom. We have hours on bottom, we want hours on bottom. We have meters on top, meters on top. So we have done exactly what we need to do. Now all we have to do is multiply and we'll have our answer. 300 times 1,000, 300 times 1,000, we get 300,000. I'm going to erase this so I can have room. 300,000 meters in 1 hour. Because 1 times 1 is 1. So, if this train was moving at 300 kilometers an hour, it's moving at 300,000 meters in 1 hour. Let's go ahead and try some more problems. I feel like you guys may be getting this. Alright. Example 5. This is where I'm going to challenge you a little bit. We're going to change things up. Go ahead and pause, copy down this problem. Madison walks at a speed of 7 feet per second. How many inches per hour is this? So in this problem, I'm going to make you change 2 things. We're going to change the top and we're going to change the bottom. But we can do it the same way that we changed our previous problems. Whatever we have on top, we cancel out by putting it on bottom. But we need to know our units of measurement in order to do that. So we know that she goes 7 feet per second. So we have feet and we have seconds. Our question is, how many inches per hour is this? So in this problem, we're going to have to change feet to inches. We're going to have to change seconds to hours. So we're going to be using a lot of math here. So, start with feet and inches. Well, we know that there are 12 inches in 1 foot. So I can change feet to inches because I have everything right here. Now, we didn't write the information of how many seconds are in an hour, but we do know something about seconds, so let's write that down. There's 60 seconds in 1 minute. Okay, so we know something about minutes then. We know that in an hour, there's 60 minutes. So 60 minutes equals 1 hour. So these are the 3 different units of measurement we need because we have minutes and hours, we have seconds and minutes. So we have seconds and hours that we're really changing to. We have inches and feet, which is another thing we're changing to. So we go back to our original problem. We're going to write this like a rate. We know that Madison walks 7 feet in 1 second, or per second. Our job is all the way down here to figure out how many inches she goes in an hour. So we need to go from feet to inches, seconds to hour. And we're going to do that by following our rule right up here. So, feet, and we're going to change those to inches. Well, if we want to cancel out a unit that's on top, we have to put that unit on bottom. So 1 foot is 12 inches. And again, if it's on top, it's on bottom, it cancels out. Feet cancel out. So now I have inches and seconds. But I don't want to know how many inches that she goes in a second. I want to know how many inches she goes in an hour. So now we have to change seconds to hours. So we look down here. Is there something that can help me change at least a second to some other unit of measurement? Well, here it says that 60 seconds is 1 minute. Well, I see that seconds is on the bottom. If I want to cancel out seconds, since it's on the bottom, I have to put my information that I know with seconds and put seconds on the top. So there's 60 seconds in 1 minute. Now, if we look, since there's seconds on bottom, there's seconds on top, those are going to cancel out. So now, we know how far she's going in inches, since that's the only thing on top, in a minute. So if I asked you how many inches a minute she went, we'd be able to figure that out if we just solved it now. But the question didn't ask how many inches she went in a minute. The question asked how many inches she went in an hour. So we have to actually keep going with this and canceling out units. So we have minutes on bottom, and we have one that has minutes and hours. We're going to use that to get our final answer. Since we have minutes on bottom, we need to put this information where the minutes are on the top. So times 60 minutes over 1 hour. Now, since minutes are on bottom, minutes are on top, those are going to cancel, and now we have actually successfully done this problem. We're going to go ahead and multiply everything on the top going straight across. 7 times 12 times 60 times 60, I'm using a calculator, we get 302,400. 1 times 1 times 1 times 1, that's 1. So, if Madison is moving at a speed of 7 feet per second, that means she's moving 302,400 inches in 1 hour. So I decided we have one problem left to do. This is our last problem. A car travels at a speed of 60 miles per hour on a trip. What is the car's speed in feet per second? So I'm going to underline all the important information. We know that it goes 60 miles per hour, so I'm going to write 60 miles in 1 hour. What is the car's speed in feet per second? So all the way over here, I'm going to write feet, and I'm going to write seconds. So looking at this problem, this means we're changing miles to feet, and we're changing hours to seconds. So we're going to go ahead and solve that. And at the very end, I'm going to teach you how to make a unit rate. So we need this information. What do we know about miles and feet? Well, we do know there's 5,280 feet in 1 mile. And then hours and seconds, well, I don't know anything about hours and seconds, but I do know that there's 60 minutes in 1 hour, and I know that there's 60 seconds in 1 minute. So what I did here is I wrote these like a fraction. The fraction doesn't matter. We can flip that fraction, we can move that fraction. We're just using these fractions to solve our problem. So, well, since I have miles on top and I want to change it to feet, I need to put miles on bottom. Okay, miles are on top, miles on bottom, those cancel. So now we're just looking at feet. Since we have hours on bottom and we want to change that to seconds, we're going to look at changing hours to minutes first. Well, hours is on top, and this one, hours is on bottom, so I can't use that. What I have to do with that fraction is actually flip it. I'm going to say that in 1 hour, there's 60 minutes. So we're using the information about measurement that we know and solving it by writing it as a rate, but we can flip that rate any way that we want. Hours are on top, hours are on bottom, that cancels out. So now we're in minutes, because that's the only thing that's on the bottom. And on top, we're on feet. Feet is good. We need to change minutes to seconds, so we're going to use this right here. Well, I see that minutes are on bottom, so I'm going to, again, take this fraction here, flip it, so minutes are on top. So I'm going to multiply by 1 minute over 60 seconds. Since minutes are on bottom, minutes are on top, they cancel out. Looking at this, the only thing that's on top is feet. That's what I want. Looking at this, the only thing on bottom is seconds. That's what I want. So all we have to do is multiply everything on top, then multiply everything on the bottom. So I'm going to go ahead and multiply. 60 times 5,280. That equals 316,800. 1 times 1 times 60 times 60. So I'm really just going to do 60 times 60. 60 times 60. 3,600. So in this problem, my answer is 316,800 feet and 3,600 seconds. If I want to change this to a unit rate, now this question didn't ask us to change it to a unit rate, but if we had to change it to a unit rate, all we have to do is do what we did in lesson 1 and divide by the bottom on the bottom and divide by the bottom on the top. And this will change it to a unit rate. So I'm going to take 316,800 divided by 3,600, and we get 88. 3,600 divided by 3,600 gives us 1. So this means that we have 88 feet in 1 second. Now, that's the unit rate. This is actually my answer to the question, but I want to show you how to get to unit rate. Even when we have big numbers, we still use the same rules that we did in lesson 1. So, that's it for today's lesson. Make sure you like that like button, make sure you subscribe, and hit that bell with your elbow if you have to, but be ready for class tomorrow.